Hello everyone. Welcome to the online course on domestic equipment maintenance. Today I'll start this session with CRT monitors and television, which belongs to module 12 on video equipment basics. This module is divided into 3 sessions. In session 1, it was discussed video systems, basics and working. The second session is on CRT monitor and television, which will be discussed today. And in the third session, it will be on LED display and projector, operation and maintenance. So the content that will be highlighted in today's lecture are construction of cathode ray tube, working of cathode ray tube, functioning of CRT in television and monitors, and safety measures to be taken while using CRT. So the main objective of these lectures are to explain the working of different parts of the cathode ray tube, to familiarize with the working of the cathode ray tube in television and monitors, and to understand the function of CRT in colored and black and white TV. So let us start with the question, what is cathode ray? Cathode ray is a kind of ray. So in the absence of air within a glass tube containing 2 electrodes, under the influence of an applied voltage, a fascinating phenomenon is observed. The emergence of stream of electrons, commonly referred to as electron beam or cathode rays. The cathode, connected to the negative terminal of the voltage applied, emits electron that create a glow on the glass surface behind the positive electrode. So scientists initially used high electrical potential to ionize gas atoms in Crookes tube, creating cathode rays. But in modern days, vacuum tubes are used in the process of thermoionic emission with a heated wire filament as the cathode. So in 1897, an English physicist named J. Thomson, he successfully deflected the cathode rays in one of his experiments. However, it was German physicist Carl Ferdinand Braun who came up with the earliest version of CRT in 1897, and it was known as the Braun tube. It was a cold cathode diode with a phosphor-coated skin. This device became the first display device, and one German professor in 1906 successfully demonstrated that this CRT is perfect display device. Since then, CRT has become an integral part of modern television. Now let us discuss what is cathode ray tube, which is shortly called CRT. So cathode ray tube, as I said, it is also known as CRT. It's a device that operates on the principle of transforming electrical input into a visual signal. It may interest you to know that the cathode ray tube, also known as Braun tube, it is still utilized in various electronics like oscilloscope tube, TV set or computer monitors. A CRT is essentially a vacuum tube that contains one or more electron guns. These guns emit electron beams which are then redirected to produce image on the phosphorescent screen. Here you can see some images of monitor, TV and one CRO, cathode ray oscilloscope. So these are some examples where cathode CRT is used. And CRT are capable of displaying a broad range of visual electrical waveforms, radar targets and or other occurrences. CRT have been utilized as memory device where the screen is not intended to visible to others. Now let us discuss what are the major components of a CRT. So to construct a CRT, we need a evacuated glass tube, an assembly of electron gun, an assembly of the deflection plate and the screen. So let us discuss these components one by one. First, let us discuss evacuated glass tube. So this is a glass tube that is canonical in shape and it is highly evacuated to maintain a vacuum. It has several electrodes for its support. The inner wall of a CRT situated between the neck and the screen, and it is usually coated with aquadog, which is a very good conducting substance. This coating is connected to the accelerating anode, allowing any electrons that strike the walls to be returned to the anode, thus preventing the walls from being charged to a dangerously high negative potential. Now let us understand why we need evacuated glass tube for this purpose. Here the term evacuate is used to mean that there should not be any air, water molecules or any other contents in the tube, and it has to be maintained at a very low temperature. And it has to be maintained at low pressure. At normal pressure or at high pressure, the electrons will not feel free to move, and hence the tube is maintained at low pressure to let the electron move freely. The variation of negative potential on the grid will affect the number of electrons that reach the anode and subsequently strike the skin, which in return will impact the brightness of the pattern displayed on the screen. Now let us come to the second component, that is assembly of the electron guns. The electron gun assembly utilizes various components to produce a concentrated stream of electrons. These components includes an indirect heated cathode, a control grid, a focusing anode, and an accelerating anode. The cathode, made up of nickel and coated with an oxide layer, generates a large number of electrons. So here in this picture you can see a electron gun, and there are many electron guns of different generations, starting from the very first when it was black and white electron gun up to color TV electron gun. The control grid, which surrounds the cathode and has a small circular opening, helps to keep the electron beam narrow by holding a negative voltage in relation to the cathode. Meanwhile, the focusing anode uses a positive voltage to concentrate the electrons into a precise point. Finally, the another anode, that is the accelerating anode, applies a high positive potential of approximately 10,000 volt to accelerate the electron beam to a high speed. Now when the focused and accelerated electron beam strike the screen, it creates a pinpoint of light serving its intended purpose. So here in this diagram you can see the components part by part. In the initial part, it is the cathode, grid, focusing anode, and then accelerating anode, and there is another called pre-accelerating anode. So these are the components which are making the electron beam accelerated towards the screen of the CRT. Now let us talk about assembly of the deflection plate. This system includes two sets of deflecting plates inside the tube which deflect the beam, that is the electron beam. Now one set is called the vertical deflection plate, while the other is called the horizontal deflection plates. Here in this diagram you can see both vertical and horizontal deflection plates, and the electron beam is allowed to pass through these deflection plates. The vertical deflection plates are mounted horizontally in the tube, and by applying the correct potential to these plates, the electron beam can travel up and down vertically on the screen. Again, inside the tube, the horizontal deflection plates are placed vertically, and by applying the correct potential to these plates, the electron beam can move horizontally right and left on the phosphor screen. So, let us discuss about the screen. So, first here in this diagram you can see on the right hand side it is the phosphor screen. The inside face of the tube is the screen, which is coated with certain fluorescent material such as zinc oxosilicate, zinc oxide, etc. When the high velocity electron beam hits the screen, a pinpoint of light is seen. This type of fluorescent material used determine how colored the spot will be. The screen has tiny phosphor dots that emit red, green and blue lights when it is hit by the electron beam, and it creates the images that we see on the screen. Now let us discuss about the working of the CRT. When the cathode heats up, it generates many electrons that travel through the control grid to reach the skin. Now the control grid controls the flow of current, regulating the number of electrons that pass through it. So here in this diagram you can see the cathode from where the electron beam is generated, and it is then taken towards the phosphor screen through the accelerating deflection plates. It is then taken towards the screen through different components of the CRT like focusing anode, accelerating anode, vertical deflection plate and horizontal deflection plates. So all these components act together to get the desired picture on the screen. If the negative potential of the grid is high, fewer electrons will pass through it. It will resulting in a small spot of light when the electron beam hits the screen. So here at the center of the screen you can see a dot like point, which is the point created by hitting the electrons beam on the screen. Now by decreasing the negative potential of the control grid, the brightness of the light spot on the screen can be increased. After the control grid, the electron beam is focused and accelerated by the anodes, which have strong positive potential. The electron beam creates a spot of light at its center when the deflection plates are not given any voltage. When voltage is applied solely to the vertical deflection plates, the electron beam and the resulting light spot will be deflected upward. Reversing the potential on the plates will cause the light to divert downward. Additionally, by applying voltage to the horizontal deflection plates, the light spot can be bent horizontally. The inner surface of the screen is coated with tiny phosphor dots that emit light in three primary colors: red, green and blue. When an electron beam hits these dots, then they'll emit lights and then they create the desired image on the screen. The electron beam is produced by an electrode charged negatively, and it is controlled by magnetic field producing deflection coils. The electron released from the electron gun illuminate the phosphor dots on the CRT TV screen. The deflection coil produce magnetic fields that guide the electron beam to hit any phosphor dot on the screen. The CRT TV screen has 525 scan lines which are drawn 60 times per second by the electron gun in alternating odd and even lines. As a result, we see a continuous image of the three bright fundamental colors drawn by the electron gun. The distance between the electron gun and the screen also limits how thin your CRT TV will be. So, while building the CRT TV, this distance has to be taken care of. It is crucial to go into the technical facts of how television functions and how the color is produced on the screen to comprehend why black and white is not regarded as a color TV. Over time, television technology has advanced dramatically, going from black and white to color displays. So now let us discuss what is the difference between black and white TV and colored TV on the basis of this CRT. The earliest type of television, as you know, were black and white or monochrome TVs. Only grayscale visual ranging from pure white to completely black could be shown on these TVs. These were built on cathode ray tubes which employed an electron beam to scan a screen covered with phosphor. A grayscale image was produced because the brightness of each pixel on the screen was dictated by the brightness of the accompanying electron gun. While on color TV, on the other hand, a separate technology known as RGB color model is used to deploy varieties of colors. Red, green, blue are the primary three colors that the RGB model blends in varied intensities to create a wide range of hues. So here in this image you can see an electron gun on which the color TV models is based on. So it has three electron gun which are red, blue and green. Now color TV use three independent electron canal, as I have said right now, each of which corresponds to one of the basic colors as opposed to a single electron beam in black and white TVs. These cannons fire electrons at phosphors, and when they hit, they produce red, green and blue light. The intensity of each electron gun can be adjusted to produce a variety of colors, and additive color mixing is the term for this procedure. So now here you can see on the phosphor screen you have red, blue and green spots, which are the spots where heated by the electron guns. On the left hand side you can see three guns, which are the three electron guns used in a color TV. On the top image you can see the one side of the electron gun where you can see there are different pins for heater, focus and for different colors. So this is a perfect picture of a electron gun which generate color images on the screen. Now here is a comparison picture. On the top you can see the electron gun used in black and white TV, and at the bottom you can see it's a colored electron gun. On the top it is the first black and white electron gun used in TV, and on the right hand side you can see one-sided view of the electron gun of the colored and black and white TVs. Now what is the difference between colored and black and white TV? The technology utilized to create the image that appear on the screen distinguishes black and white and color television in their core functionality. Now grayscale is used in the operation of black and white TVs, whereas RGB color model is used in the creation of wide range of colors in color TVs. Monochrome images are the only one that black and white TVs can display. As opposed to black and white TVs, color TVs can depict a wide range of colors, giving viewers a more lifelike and dynamic visual representation. Now let us talk about digital television. In contrast to old analog television technology, which utilizes analog signal, digital television, which is also called DTV, involve the transmission of television signal using digital encoding. To transmit programs, digital TV employs a digital signal rather than a radio transmission. A digital transmission transmits information as binary bits of 1 and 0s, which are reassembled at the receiving end to generate vision and sound. It was regarded as an inventive advancement at the time of its invention, and it is constituted the first significant evolution in television technology since color TV in the 1950s. Modern digital television is broadcast in high definition television, which is called HDTV, and which has a higher resolution than any analog television. It often has a widescreen aspect ratio, commonly 16:9, as opposed to analog TV, which have smaller format of 4:3. Now let us discuss some advantages of having CRT monitors. First, they are significantly less expensive than present-day monitors such as LCD or LEDs. Second point, the responsiveness of a CRT monitor is excellent. They are very fast and the interaction time of less than 1 picosecond. Third, native display resolution is not available on CRT monitors. CRT monitors are appealing, especially at any resolution. They often provide a deep black and high contrast level, which is ideal for seeing even in low light conditions. So these are few advantages, but there are some disadvantages of CRT monitors also. Let us also discuss them. They are massive in size and requires more area for installation. Second point, CRT monitors produce heat and consume more energy, so it can affect your electricity bill if it is used for more time. Third, while experimenting with visual and resolution, they do not perform to their full capacity. They are also less appealing than new generation LCD and LED monitors. Again, higher magnetic field generated by the CRT can damage any nearby magnetic equipments. So one should not take a magnet near to the display of CRT. The brightness of a CRT monitor is not as good as that of an LCD monitor, and in CRT monitors, colors are less accurate. So these are few disadvantages of CRT monitors. Now, while you are using a CRT monitor, you have to take some safety precautions. So if you use a CRT properly, neither your computer nor the display will be ever harmed. There are several CRT safety practices available to keep you safe. First point, if a CRT vacuum tube is destroyed, it can collapse. The air around it is going to surge violently into the CRT's open vacuum, producing broken glass everywhere. So this is the first point. Secondly, color CRTs might include mercury or other harmful elements. So these materials may be discharged if the CRT has snapped or cracked, posing a danger of hazardous exposure. Next point, even after the display or system is switched off, a CRT can carry charges and can build up secondary charges after the power has gone. So one should avoid contacting the CRT immediately after the power is switched off. Next point, handling CRTs appropriately entails not putting any strain on the CRT assembly's neck, because the glass in the neck is thinner and you are not supposed to carry a CRT by its neck. It is also crucial to use CRT modules with care when lifting or lowering down. Now there are some points to be remembered when maintaining a CRT. When cleaning the screen, you have to use a soft lint-free cloth, and you have to avoid abrasive materials like paper, towels, because they can cause scratches on the monitor. Next point, you have to avoid using magnets near your monitor to prevent image distortion and discolorization. Next, adjust the brightness and contrast setting for comfortable viewing and improved image quality. The monitor contains a high voltage anode capable of holding up to 25,000 volts. If you need to make adjustment to your CRT monitor, it's crucial to discharge it to avoid any problems. Next point, avoid exposing your CRT monitor to extreme temperature and humidity, because it can damage the monitor internally. It is also not recommended to expose your CRT monitor to direct sunlight, because it can cause discolorization and damage to your internal components. So now we have come to the conclusion of this talk. To conclude, let us see at a glance what we have learned here in this lecture. We have discussed the different parts of a cathode ray tube in details. We have also learned the process by which a strong beam of electron can create image on the screen of the monitor. This lecture has also covered the difference between a black and white television and a color television. Black and white TV rely on a grayscale system and hence lack the technology needed to produce a wide range of colors. They are not termed color TVs. On the other hand, color TVs use RGB color model to provide vibrant and varied hues on the screen. The technology is significantly advanced. The switch from black and white to color television improves the viewing experience and enables a more realistic visual to the viewers. After going through this lecture, one should be able to answer the following questions. What is the cathode ray tube and how does it work? Next, what is the shape of the glass enclosure of a CRT? What are the components of an electron gun assembly? Next, what is the function of the cathode in an electron gun assembly? Next, how does the control grid help to keep the electron beam narrow? Next, how does the accelerating anode accelerate the electron beam? Next, what is the function of the focusing anode in an electron gun assembly? What is the function of the anode in a CRT? Next, how are images created on a CRT screen? Next, how are scan lines drawn on a CRT screen? Next, what is the difference between black and white and color television in the core functionality? Next, what is the technology used to create images on black and white TVs? Next, what is the RGB color model and how it is used in color TVs? Next, how do color TVs produce a variety of colors? Next, how do color TVs differ from black and white TVs in terms of the range of colors they can depict. So these are few questions for you. I hope the content presented in this session will expand your knowledge. Please post your questions and queries and give feedback on the session. Thank you.